Alrighty, so 1.8, using transformations to graph functions of the form y equals a function k x minus d plus c. Okay, so this is what we learned yesterday. Well, actually, we learned part of k. So before, you guys knew the a, the d, and the c. Okay, now we're inserting this k value here. So notice that the a is in front of the function, whereas k is inside of the function. All right, so you don't really need to know this as much, but I'm going to list out the steps that usually happens when you're doing transformations. Okay, so you want to do first is horizontal and vertical stretch or compress. And I'll show you with the formula what this means. Okay, so in the formula you'll notice it's a bit off. Okay, horizontal and vertical stretch and compression. Then the second step, we'll do the reflections. And lastly, we do the translations, so shifting left, right, up, or down. Okay, so when we're doing this, and it'll be evident when we do the formula. Okay, so we're doing, in the formula, we'll do the stretch and compressions first. Okay, then we do the reflections and then the translations. Give you guys a minute to get that down. And actually, I'm going to write out the formula that we'll be using. So it's x divided by k plus d, comma, ay plus c. Okay, again, we're doing horizontal and vertical stretch and compressions. That is evident in the formula here. Okay, that along with the reflections if it's negative, and then we add or subtract the translations. Okay, so number one tells you to transform the following function. So the original function is f of x equals the square root of x. That is our parent function. Okay, this is our parent function. And now we want to do these transformations to the parent function. Okay, so just a reminder that the parent function is square root. So when we have a square root function, it starts here. Okay, it starts at the origin, and then it's a half parabola opening to the right. okay, that is in quadrant 1. Now what we're doing is we're going to be reflecting it actually twice over the x over the y. Then we have a vertical compression by a factor of 1/2, and then we have a horizontal compression by 2. Okay, so we want to know, after we do these transformations, so these negatives and the negatives, the 1/2 and the 2, what happens to our graph? Where is it now? So after we move it, stretch or compress it, reflect it, where is the parent function now? Okay, so this is how it works. We have to start off with the values for the parent function. Okay, so it's the square root. So the numbers we use is 0, 1, 4, and 9. I'll just use 4. If you want to go to 16, you can. Okay, so those are the values we use for the parent function. And when we plug these values in, we get 0, 1, 2, and 3. So in order to do the transformations of using the formula, what you have to have first are the values of the parent function. Okay, so you kind of need to know these off by heart just to be faster, or you just plug in values in and came up with a table. Okay, and then we want to know, after we do all the transformation, what are our new points? Okay, so we want to know what are our new values after we do the transformations to the square root function. So this is how it works. So we're going to use this formula here. So the first part represents the x value. The second part represents your y value. Okay, so we'll give you a point on the graph. Okay, so the first is your x value, the second is your y value. Let's just move this over a bit. Okay, so what we're going to do is plug the values in here. Okay, so let's start with the first point. So let's start with 0, 0. Okay, we're going to plug 0 into our x. And we're going to plug 0 into our y. And then from the equation, we have to fill in the rest of the values. Okay, so what is the negative half? What letter does that represent? The negative half. What letter does that represent? The negative 1 over 2. The a value, good. So that represents the a value. If you want, you can leave it as, you can put it into a decimal. So our a value is negative 0.5. So negative 0.5. Okay, so we're substituting negative 0.5 into a, and our y is 0, because we started off with 0. I'm just going to put this here and here. Okay? Now let's move along. What does the negative 2 represent? What letter does that represent? The k value, good. Who's this? Esther, thank you. So negative 2. So we're going to plug negative 2 where the k value is, right? So our k is negative 2. And lastly, so we don't have any more numbers. So what's the value of d and c? What's the value of d and c? Zero. Good. So the first one is not going to, we're going to end up with the same number. Okay, now we solve. I know this one's not very exciting. So if you do 0 divided by negative 2, it's 0, plus 0 is 0. Okay, at this point it's not going to change. Negative 0.5 times 0 is 0, plus 0 is 0. Okay, so even with all the transformations, our first point is 0, 0. Actually, let me put this in red. Okay, so we found our first point. Now what we're going to do is go down the table and we're going to use the next point. So instead of 0 and 0, we're now going to use 1 and 1. So I'm going to erase these zeros for the x and y, because they're x and y. And now we're using 1 and 1. So we're going to apply the transformations to now the point 1 and 1. So right now we do 1 divided by negative 2 is negative 0.5 plus 0 is negative 0.5. And the next one, negative 0.5 times 1 is also negative 0.5. Okay, so now our second point is negative 0.5. Negative 0.5 and negative 0.5. And then we keep repeating the process for the table of values. So now, instead of 1 and 1, our next point is 4 and 2. So we're plugging 4 into the x and 2 in the y. And we're going to find out where the new value is. So 4 divided by negative 2 is negative 2, plus 0, it's still negative 2. Negative 0.5 times 2 is negative 1. So our next value is negative 2 and negative 1. Any questions so far? Okay, now we're going to do our last value, 9 and 3. So I'm just keep changing this value here. Just keep changing the x and y. So we have our 9 now and 3. And by the way, I'm using decimals because we're going to be graphing it. So 9 divided by negative 2 is negative 4.5. Plus 0 is negative 4.5. Negative 0.5 times 3 is negative 1.5. So our last point will be negative 4.5 and negative 1.5. So if you were to graph this, it would look something something like that. And obviously this is not exact. The question didn't ask me to graph, but if I had to, I'd just plug these values. So after I have the parent function, I did a vertical compression of a half, and then a horizontal compression of a negative a half as well. So I have a half. And then we have two negatives, so it got reflected over the x, and then it reflected over the y. So it got reflected twice. Okay, and then that's your new graph. And this formula applies to all functions. Okay, this applies to all functions. Well, it's linear, quadratic, square root, reciprocal, or our absolute value. Let's give you guys a minute.